About what modal logic is and semantic validity for modal logic. This video 2.4 is going to be about proof theoretic validity for modal logic, for system K of modal logic. So proof theoretic validity, remember this is the Tableau rules, and these I think probably are more confusing than they are helpful, but I'll go through these very briefly and then I'll show you exactly what I'm talking about. But so where Tableau is going to look a lot like an initial Tableau it looked for the propositional calculus. You'll start with your initial list, and this is of course the premises and the negation of the conclusion, right? Just like we were doing before. The initial list is the first branch at whose nodes occur the premises and the negation of the conclusion. Every premise is going to be A, and then you're going to put comma 0. So if there's a premise A, then you write that premise and then comma 0. So what do I mean by premise A? I mean whatever that premise is. So if the premise is, P and Q, you'll write P and Q comma 0. Why are you writing 0? 0 means world 0. And that's where you're always starting off on world 0. And then whatever the conclusion is, you're going to write not that thing and then comma 0. So for example, let's say we were working with P and Q. Does that entail necessarily P? Something like that. And you'd write P and Q comma 0. This is not P is the conclusion, so you'd write, necessarily P is the conclusion, so you write not necessarily P comma 0. Every node, when you're doing all the trees and all that stuff, every little node is these little, well, that doesn't look very good, but there's an arrow. Every one of these little dots right here, right? These little dots right here. Every node has either a formula and a natural number, right? Natural number means 0 or 1 or 2, something like that. Or something of the form IRJ, where I and J are natural numbers. IRJ is going to be the world related to another world. Now, these are all just, remember, proof theoretic validity. You're just throwing down a bunch of rules and you're not making any reference to what the stuff means until the very end. But intuitively, and the way this was set up was so that what you got here is you have your premises and your conclusions, and the zeros mean world 0, and at every node you're going to have a formula which has to do something with with these formula up here. And the natural number on the side is going to be the world that you're talking about. Or if you have IRJ, that would be something like this: 0R1. World 0 relates to world 1. That's what you're going to be doing at these nodes. And of course, then so you make your initial list and you apply your Tableau rules, and the Tableau is complete if and only if every rule that can be applied has been applied. So you have to apply all the rules and then it's complete. Your branch is closed if and only if there are formulas of A, comma I and not AI on 2 of its nodes. So that's a branch, remember. So if I have something like, let's say my Tableau looks something like this, a branch, let me change my color, I'll get a highlighter instead. A branch would be something that goes from the root to the tip. And so somewhere on here, I'm going to have AI and not AI. So it has to be the same world. If they contradict in different worlds, you don't really care. Okay, that's the only way that a branch will close, and the branch is open if and only if it does not close. All right, so same rules that we had in the propositional calculus. Only differences are the worlds that you're talking about, the worlds. So comma I at the end of all of these things. It's the only difference that you have for these rules. Now here are the Tableau rules, the modal rules. So you'll notice that if you have a knot in front of a box or a diamond, you want to get rid of that knot in the front. Okay, and the way you'll do that, this I showed you before in one of the videos before, how not necessarily A means possibly not A, and how not possibly A means necessarily not A. Well, so we just apply those, we make those rules. All right, so not necessarily A, comma I. If you have that, you make that possibly not AI. And if you have not possibly AI, you make that to necessarily not AI. Yet you get these guys out there so you can apply one of these rules to them to get rid of those boxes and diamonds. Because we're going to be worried about, you know, truth values at worlds. We're going to want to get those boxes and diamonds out of there. All right, so if you have a box A, necessarily A at world I, and if you have an IRJ, then you can get an AJ. So what does that mean? Let's say you see necessarily A, that is a huge box, necessarily A at world 0, and somewhere along your branch you have a 0 relates to 1, then you can say A1. You can make this claim. Alright, and you'll have to make it for every time you see an IRJ. So every time 0 relates to a world, you're going to have to make an A that world. If you see also somewhere on your branch it happens to be 0R2, 0 relates to 2, you're going to have to make an A2. So here's one weird thing about this, about the box, is that you never check the box, because it's always possible that you can use that rule again. For all the ones that we've done before, once you use the rule, you're done with that formula, you check it, right? So to let you know, oh, by the way, don't come back to this. But for box A, it's always possible that later on you have something that you can reapply this box to if 0 ever relates to some other world. So that's what you do with the box, and it makes sense because you're saying necessarily A at world 0, and we said what that means is that every world that 0 relates to, world 0 relates to, this means that A is true at all those worlds. So if 0 relates to itself, then A is true at 0. 0 relates to world 1, then A is true at world 1. That's what necessarily A means. For diamond A, that's possibly A, you don't have to have an IRJ somewhere on the branch already. All right, you're going to make your new IRJ, and J is going to be new here. So J can't be anything else that you've already had on that branch. If something branches off and on one side you have a J and on the other side you have a diamond, it doesn't really matter if the branches have split already. But J should be new to that branch. So if you come across, let's say, a diamond, possibly A at world 0, what that means is there are some worlds that 0 is related to at which A is true. That's what possibly A as world 0 means. So you can make the conclusion 0 is related to some world, and we'll just, since let's pretend there's no 1 on this branch already, we'll just pretend we'll just label that world 1. It doesn't really matter what you label the worlds, I mean, we want to go in order of number just to keep ourselves straight, but it doesn't really matter if you call our world 20, or it doesn't really matter. It doesn't change anything. Alright, so 0 is related to world 1, and at world 1 A is true. So A at 1. Alright, let's do some examples. I got 3 examples for us. The first one is this right here. We want to show how necessarily if A then B and necessarily if B then C entail necessarily if A then C. Here I have all my propositional calculus rules with the little i's attached to them, and here I have my new modal rules. So let's go ahead and start. First thing I'm going to do, I'll split the and using this rule, right? I'll split the and into these two things, so check, done. The next thing I will do, it looks like I have two necessaries, and I have the not necessary, and that's an easy one to get rid of. So yep, I'm going to apply this rule to this, and that gives me that, so I'll check that guy. I have now possibly not if A then C 0, and I have necessarily if A then B 0, necessarily if B then C at world 0. Now notice how necessarily whatever at that world, you also have to have that world related to a world. Well, when you first start off, your 0 is not related to any worlds, right? So what I'll have to do is, if I don't have 0 related to any worlds, I'm gonna have to start with a diamond, right? Where J is new. So the only thing I can do right now is the diamond rule, and that's going to give me 0 is related to 1. There are no 1s up here, so 1 is a new to this branch. So 0 is related to world 1, and this part after the diamond is down here. Not if A then C at world 1. Now I have 0 related to 1. So now these boxes, oh, by the way, check that. These boxes, these necessarily at world 0, now since 0 is related to world 1, I have to go ahead and use this rule for both of these things. So this rule will apply to both of these guys, and this, right? So the first one will be if A then B. Actually, oh, oops. I did this one first. Sorry. I did this guy first and this one. So not if A then C turns into A1 and not C1. And then I did this rule. So I got I applied the box and IRJ rule to get if A then B at 1 and if B then C at 1. Alright? And of course, if A then B, I will apply this rule to it. And I get not A1 and B1. And then I'll apply the same rule to if B then C. And I'll have to apply it on this way because I have A1 and not A1 here, right? I apply it over here if B then C, and I get not B1 and C1. B1 and not B1, close. C1 and not C1, close. This is all branches closed, so this entails that. Now I have this guy right here. It says that possibly if possibly A and B, then possibly A and possibly B. So I'm going to see if that one follows by first applying the not. Oh, let me go back one. So this is the conclusion. There are no premises, right? So what I have to do is I have to negate this conclusion by itself. Do that, and that's what this is here. And when I negate the whole thing, it refers to this if-then statement right here, because the rest of these are in parentheses. There is this guy hanging outside of the parentheses, but it's applying to this, right? It's kind of like the not sign. It applies to this one thing right here. I'm looking at whatever connects these two things. So I'm going to use the not if-then rule, which is this rule right here, and I'm going to get this and not that, which is this right here, right? So possibly A and B 0, not possibly A and possibly B at 0. Alright. And I have a not and rule, which splits them up, and I have the possibly rule, which doesn't split anything up. But I'm going to go with the not rule first because these diamonds and boxes can be tricky. But you could probably done the other way if you wanted to. So not A and B. So not possibly A 0, not possibly B 0. Then I have the diamond rule that I have to worry about. Oh well, I can actually switch these out. Yeah, that's what I did. So I have the not diamonds. Those are easy to swap out, right? I just use this rule to get them to the box rule. So not possibly A is the same thing as necessarily not A, and not possibly B is the same thing as necessarily not B at 0. And then I have, so I have these, this is done, and this is done, and this is done. Of course that's done too. Well, now I have these boxes, and there's nothing you can do with the boxes unless you have the world related to some other world. So you kind of can't do anything with these just yet. So you have to go to the diamond rule, which is this rule, and make 0 related to some world that's not on there yet, which is world 1, 0 related to 1, at 0 related to 1, A and B at 1. Alright, so I now have 0 related to 1, A and B at 1, and the AND rule is really easy, so that's the one I'm going to do next, right? It's this one right here. A and B gives you A, B. So A and B gives you A, B, 1. That's done. Then I have the box rules, which is this one right here for both of these guys. So I have necessarily not A at world 0 and 0 is related to 1. That means not A is true at world 1. And necessarily not B at world 0 and 0 is related to 1, so not B at world 1. And notice that only works down these branches, right? These are on different branches, so necessarily not B, 0 related to 1. I'm not trying to swap them over here on the branches. You can't do that. These are separate branches. Now I have a not A1 and an A1 closed. I have a B1 and a not B1 closed. This does in fact work. Let's do one that doesn't work. We're going to show this one, this whole thing, possibly P, if possibly P and possibly not Q, then possibly necessarily possibly P. We're going to say that that doesn't follow. So we're going to have to again take the conclusion and negate it. There are no premises, so don't have to worry about those. So here's my initial list, just this thing right here. Remember that the not is going to apply to whatever operator in here connects both of these things, and that's this one right here. So I'm going to use the not if then rule, which is this guy right here, to get this thing and not this thing. So possibly P and possibly not Q at world 0. Not the case that possibly necessarily possibly P at world 0. That probably sounds like it hardly makes any sense, right? You're just saying the same thing over and over again. Yeah, I've seen actual philosophical problems that look just like this. So they're real, but don't worry, we're gonna make this make sense in a second here. Well, when I look at both of these two things, hand signs, those are really nice, right? They come out really pretty like this. So I'm gonna do that one first, probably, right? Yeah. I have for some reason I swapped them on accident. So possibly P and possibly not Q at 0. That's what this one is. So these two are done. I have the next thing I have is this guy right here. All right. So I'm going to use my not possibly rule right here to get this thing, right, to swap these two things around. So the possibly turns into a necessarily, and the not goes over here, and I get this thing right here. And remember, if you don't have a 0 related to some world and you have a box, then you can't do anything with that world, or with with this formula, right? So I have these two guys that are still left open. I have this guy that's just hanging out and can't do anything. I'm going to have to work with the diamonds. So I'm going to do this one first. I'm going to go right here first and say possibly P at 0. Then there must be some world that's not here yet, 1, and 0 is related to that world, and at that world P is true. So 0 related to 1 and P1. And then I can do something with this thing finally, right? So I will make it, I will use this rule right here. I can check this guy, but I can't check this guy because remember, 0 might be related to some other world too later on here. So P1, then we got this thing right here. I have the not hanging out here, so I'm going to want to swap that in. I get possibly not, possibly P1. Then I have 2 diamonds here. I'm going to go with this one. This one's done, by the way. And go world 1's related to world 2. This is this rule, by the way. Now I had to do that because J has to be new to this branch, so there's no 2 here, so I'm gonna have to use 2. I couldn't do 1 because 1's not new to this branch. So 1's related to 2, and at 2 not possibly P2. Of course, then I take this thing and use this rule and make it necessarily not P2. Now I still have this possibly not Q0 hanging out here, so I have to deal with that one. I have to make again 0 related to some world that's not on here, and I already have 2 worlds on here, so 0 is going to have to be related to world 3, and at world 3 not Q is true or Q is false, whatever way you want to say that. So now 0 is related to world 3. Notice again, I have this guy where it's at world 0, I have a box. So that means if 0 is related to any other world, I have to worry about that. So I'm going to have to make this thing down here, right? 0 is related, where is it? This is probably starting to get a little crazy. Let me erase all the ink on this slide. So here's what we're working with this one. We're worried about this one. This was made by applying this rule to this. I had to get a 0 related to 3 and a not q at 3. So now I have to apply this rule to here because of this and get this, which is, it's just this back end, not necessarily possibly P3. I can apply this rule. I get possibly not, possibly P3. Then I could apply this rule and say 3 is related to some world 4, not possibly P4. And what do I have left? I can swap out this to a necessarily. And I do that, and I have nothing else going on for me at this point. 4 is not going to relate to any world. I've applied all the rules that I can apply. The necessaries don't have any other worlds that they can worry about. So I have all this craziness, and none of it closes out. So I can make a counter model. And the counter models for modal logic are going to be a little bit more complicated than they were for the previous one. We still have this right here, right? The attaching the p's, but now we have to worry about at worlds. So the first thing you've got is W, the set of worlds, right? What worlds do you have? Well, you can just go and look at all the numbers. 0, 1, 2, 3, and 4. So I have world 0, I have world 1, world 2, world 3, and world 4. The next thing I'm worried about is which worlds are related to which. Here I have 0 is related to 1, so I could say world 0 is related to world 1. 1 related to 2, so world 1 is related to world 2. 0 is related to 3, so world 0 is related to world 3. And 3 are 4, so world 3 is related to world 4. Erase all that ink. And then then I look back down on this, all this branch, this one branch, right? And this is all one branch, so I don't have other branches coming off of here. So I look at this branch, and I look at all of the propositional parameters. I have one here. Notice I'm not worried about the diamond p's. I'm only worried about just the p's, just the propositional parameters, not the formula. I have a not q3 here, and that's all I have. So at world 1, p is true. At world 3, q is false. So I'm going to say the truth value at world 1 of p is 1. The truth value at world 3 of q is false, because it's a not q at 3. So that's a little more complicated than we've had before. Before, we've done the truth value of q is 0, but we haven't had to worry about which world you're talking about. Here you're going to have to worry about the worlds, but if you've done this right, you should have these worlds already set up. I'm not going to give you anything as complicated as this on a quiz and for the practice one, so it won't be as messy as this, but you still will have to keep these things straight. Okay, now, drawing it out, diagramming out the world. So what is that going to look like? Well, the first thing you're going to do when you're diagramming out a world is you're going to look at which worlds you have and how they're related. I see world 0 is always where we start, and I see world 0 is related to world 1 and world 3, and nothing is related to world 0. So I'll draw out a line in world 1 and world 3. And then I look at world 1, and I say world 1 is related to world 2, and nothing else, and nothing's related to world 1, so I'll draw that out. If I wanted to draw this going the other way or something like that, that's totally fine. And then I see world 3 is related to world 4, so I do that, and nothing else is related to world 3. And those are all my relations. So I have all the worlds pictured out. The only thing I have to worry about now is what's true at which world. At world 1, p is true, so at world 1 I'll write a p close to world 1. Sometimes I've seen people do it like this. Sometimes, depending on what is most convenient. You just got P somewhere around there. Now world 3 Q is false, so you'll write a not Q around world 3, and then you have your world diagrammed. That is how you do the proof theoretic validity for modal logic, especially for K.